Hi guys, well it's time to show you as to how we actually are getting extra power from this machine without putting extra input in. Why this motor seems to do a lot better than a standard motor in driving a load, and what we have done to achieve that, and the effect that we have to achieve to get the results we're getting. Now first of all, as you would have seen in the first couple of videos, I loaded the secondary coil up with an LED light. The reason for that is because the LED of course is a diode as well, and you would have seen if we hook it up the wrong way around it kills the motor. This is because it was creating an opposing magnetic field within the stator winding to what we have on our rotor. In other words, a north and a north, or a south and a south. By hooking it up in the other direction, we create the opposite pole within that coil. So we have a south on the stator coil and a north on the rotor coil, or vice versa. This is what was helping in the rotation. So by adding a load to that coil, we actually added strength within the rotation of the motor. Of course the motor speeds up, and like all brush motors, the current goes down. So what we've done here is we've taken the power from that coil, looped it back into the motor after the input of our full wave bridge rectifier via the L bridge diode setup. Now what we need to do then is to remove any voltage inside the AC wave, as this only fights the current itself that's coming into the motor. We need to basically dump this energy on top of the AC wave so as it once again helps instead of hinders. I guess it's like having two garden hoses going into a T-piece and feeding it out the same size garden hose, as you're going to have the two inputs fighting each other, and the output's basically going to be the same. This situation, we take a bit from one garden hose and put it through the T-piece, and then a bit from the other garden hose and put it through the T-piece at a separate time. So what we're going to see is at low RPM we're going to have the high voltage spikes travelling through the AC wave, which is what we don't want, as that will only fight the current that's trying to go in. So we need to let the current from our full wave bridge rectifier enter the motor, and then we need to dump that on top of it. So low RPM, this cap is no good. We would need a smaller cap. Between 3,500 and 4,000 RPMs, that cap does a pretty good job at clearing up any of the voltage return inside the half wave AC. So the other addition I've made to the circuit is I've added a pulse width modulator that is being driven from our half wave AC and not DC. This has a frequency of 2 kilohertz. This has a frequency of 100 Hz. So this is now producing 20 pulses within each wave of our AC input to the motor, and then our commutator switching also adds to the top of those 2 pulses. We have pulses with inside pulses with inside pulses. So that is what we've done, and that certainly has increased the efficiency of the motor as far as RPMs and power being drawn, but I'm not sure yet as to how it's affected the torque of the motor. I have to place that fan back on it, the big one, do another test and see how we go. But now we're going to show you as to where the extra energy is coming from and how we're actually achieving that without it reflecting on the input energy required to run this motor. So we've basically looped the system and got the timing right. So we'll start it up. You can see with the PWM the motor starts by itself, which is an added bonus I guess. So what I'll do now is I have our probe going to both inputs, so both the hooks straight up, will be straight up to the outputs of the pulse width modulator. So this will show us our AC wave, or half wave, and also the pulses within that half wave, as you can see here on the scope, or hopefully you can see on the scope. So that's what we have. We now have 20 pulses inside each wave that is heading off into the motor. Now this is pretty slow RPM. So now I want to show you what we're trying to achieve. So what you can see now is the high voltage spike return from the collapse of the secondary coil. Now this is looking at the input going into the motor itself. See our half wave AC, you can see the 20 pulses from the PWM within each wave, and you can also see the high voltage spikes being returned. What we don't want is any of those spikes on the inside of the AC waveform. We want it all to be on the top of the AC waveform. So like I was saying, we need a smaller cap at this RPM to achieve that. So this cap is designed when the motor is running flat out. So we'll turn the motor speed up. Now it's not totally clean, but we are almost there. So what we have here, actually I'll drop that down one division. Now just for clarity, we're set on 1 volt on our voltage divisions, and the probe is at 10x, so each division is 10 volts. So you can see there that we have 5 divisions from our 0 volt line, and our voltage peaks on the spikes 50 volts plus. And you can see that we've got almost all of it riding on top of the AC waves and nothing inside the AC waves that is fighting the current from our full wave bridge rectifier that's feeding the motor. So we've nearly achieved exactly what we want to do. Cap at the moment is probably a little bit too large at RPM, but we're very close. So what you see on top of the AC waveform is the power that's being sent to the motor above and beyond what we're getting from our full wave bridge rectifier. Now you can also see, turn that back on, compared to the last videos, so about 338, 339 on our RPM, and we've reduced the current draw quite dramatically. And this is reflected on the watts that's being consumed by the transformer itself. And so far we're doing well, so what I need to do now is put the fan back on it, do another load test, and see if the PWM indeed has improved our efficiency of the whole setup. I do have a 20 amp pulse width modulator on order that allows you to adjust the frequency between 400 Hz and 4 kHz, so we can muck around with that and find the best frequency for the system. But so far we've achieved pretty much all what we've set out to do, and that is to dump power on top of our AC inputs experiment is helping so far. And yes, I'm still to line the second coil on the motor, so that is just another efficiency increase we can expect from this setup. That's a little better. Okay, so that's what I have so far. Just an explanation as to where the extra power was coming from. And like I said, we've actually improved the system two ways. Firstly by placing a load on the coil, and secondly by dumping that energy back into the motor itself, which we've managed to dump on top of the AC wave and get rid of most of it within that AC wave. Okay, so cheers for me for now.